Hamilton had proposed a method of dealing with the decimal in the apportionment process back when Jefferson had proposed his. And so when Jefferson's method wasn't working out so well, there was an incentive to go back and use Hamilton's method. So let's take a look at Hamilton's method next, I should say. I've got in bullets the method, but let's again use an example to show how that method works. We're going to look at a hypothetical country, this time of 4 states, with the House of Representatives 60 seats. All right, so every method starts with a standard divisor. So we're going to look at the standard divisor in this scenario. So the standard divisor is always going to be calculated based on the population of the entire country. So in this case, 8,480 people. I'm using a small number of people just because it's easier to work with than when we talk about millions of people. We're going to divide that by 60 seats. So we're going to always take the total population and divide by how many seats in Congress we have to get the standard divisor. Now the standard divisor is going to represent approximately how many people should be represented by each seat in Congress. So it's going to give us a decimal value. In this example, we get 141.3 people should be represented by every seat in this hypothetical House of Representatives. Now, I did round there. Generally, with the standard divisor, we'll round to the first decimal place. We're going to take that standard divisor now and use it to find the standard quotas, or the number of seats each state should get, the decimal equivalent of how many seats each state should get. And to do that, we're going to take that value and we're going to divide the population by that. So first state has a population of 1,230. We're going to divide that by 141.3. and come up with a standard divisor. Standard divisor here will be 8.70. We'll do the same thing for state B. 550 divided by 141.3 gives me 3.89. State C, 4,500 divided by 141.3 gives me 31.85. State D, 2,200 divided by 141.3 gives me 15.57. A quick way to make sure you haven't made a calculation mistake is add up all 4 of those numbers in your calculator and make sure you get 60 seats, because we should be distributing 60 seats. All right, when I do this, I get 60.01. Remember, we're wanted 60, but it's okay if we're just slightly off due to rounding error, because we did round each of these decimals values. We had to because they went all the way across our screen on our calculator. We did need, just for convenience sake, to round them off at some point. So we rounded them off to the second decimal point. It's pretty common to do the second or the third or even the 4th decimal point. The main thing is to watch the instructions wherever you happen to be doing it. Here I'm doing it the second, but in other places you might want to do it to the 3rd decimal point. So round off error. And this is very normal that you might have round off error when you add things up at the end. All right, now Hamilton's method does the next step the same way that Jefferson's does, which is that we're going to take the lower quotas. Lower means cut off the decimal. So we're going to get 8 seats to state A, 3 seats to state B, 31 to state C, and 15 to state D. When we add up those lower quotas, 8, 3, 31, and 15, we get 57 seats. Now we wanted 60, right? 60 was our goal. So this is, there are 3 missing. 3 seats that are not yet distributed, 3 seats remaining. So with Jefferson's method, we use this complicated system of a modified divisor to recalculate everything. Hamilton's is much simpler. Hamilton just says, hey, let's take advantage of the information we already have. Let's look at the decimals involved in our standard quotas. So it goes back to the standard quota and it says, let's look at the decimals. The first decimal on state A was 0.70. State B, it was 0.89. On state C, it was 0.85. And on state D, it's 0.57. And what Hamilton said is, isn't it just fair to give whoever has the highest decimal an extra seat? And people thought, hey, yeah, that makes sense. So in this example, state B has the highest decimal. 0.89 is higher than 0.70 or 0.85 or 0.57. So state B gets 1 extra seat. The idea is you give 1 more to that state. So state B would get 4 seats instead of 3. But now you still have 2 seats remaining. So what you now do is you say, well, okay, let's give another extra seat to one other state. We don't want to go to go crazy and give any state a whole bunch. We just want to portion them out one at a time. So the next highest decimal would be state C with 85. So we give them an extra seat. So they get 32 seats. And then the next highest, between state D, which had 57, and state A, which had 70, we would give state A with the higher decimal the next seat. And now all three of the extra seats have been accounted for. We've given away the 3 remaining seats exactly. Once we've given the remaining seats away, then there's no more left to give, and everyone else stays where they are. So D stays at 15. So now when we add this up, it should add up to 60 exactly, because we've given away just the 3 extra seats one at a time. So this right here, it is Hamilton's method for apportioning the seats in Congress. Hamilton just says, use the decimals you already have from the standard quotas. Whoever has the highest, give them an extra seat. And just keep doing that until you've used up all the extra seats. Now, the great thing about this is it will never violate the quota rule. The reason it won't violate the quota rule is because you start, every seat first goes down to the lower quota. The lower quota is the lower end of what's fair for a state. And then at most, Hamilton's method says you give everybody 1 extra seat on that lower quota. So you end up at most at the higher end of being fair for every state. So you never go beyond what's fair for any particular state. So the quota rule is never violated. So that's one advantage of Hamilton's method over Jefferson's method. Now, Hamilton's method was really straightforward. It was easy to understand. It was easy to implement. There were no modified divisors to deal with, no guess and check like with Jefferson's method. It seemed ideal, but in practice, there were some problems. And they were things that were unforeseen, that they didn't expect until they actually saw it happening. There were some things that people would consider fair that Hamilton actually violated, or the method happened to violate. Let me go through just a few of the things that kind of were unusual. They called them paradoxes that happen. For instance, adding extra seats to Congress shouldn't by itself result in fewer seats for any state. But unfortunately, Hamilton's method could occasionally cause this to happen. It was discovered in 1880 when calculations were run to determine how to change the size of Congress, and the Census Bureau found that Alabama would get 8 seats in the House when the House size was 299, but only 7 seats when the House size was set to 300. So population of all the states is exactly the same, but you increase this number of seats in Congress to 300, or at least in the House to 300, all of a sudden Alabama loses a seat. That doesn't seem to be fair. No one should lose a seat because you've increased how many seats are in Congress. So that was what we called the Alabama paradox. Another thing that happened that they saw, or they thought of as being fair, that Hamilton's method violated, they thought adding extra seats to Congress to accommodate a new state shouldn't change the apportionment of existing states. But occasionally Hamilton's method would allow this to happen, and they actually ended up calling this the new states paradox. They saw that if you added extra seats to Congress to accommodate a new state, Hamilton's method could actually unfairly redistribute and have certain states lose a seat and other states gain one, even though their populations hadn't changed. Again, that was just something that could have happened when you added a new state in. And then the other thing they saw happen was something called the population paradox, which is that apportionment changes should always reflect the population growth, with faster states gaining seats at the expense of slower growing states. But Hamilton's method could actually allow slower growing states some advantage in some situations. So Hamilton's method could actually allow a slower growing state an extra seat compared to a state that's growing faster. And that didn't seem fair as well. So in the end, Hamilton's method ended up being jettisoned as well. So neither, in the long run, Jefferson and Hamilton's method were both shown to have problems, and both were dismissed.